Alright, hello everybody, welcome to I have no idea, fourth episode of Lua and Python coding in Leetcode. And today what we have is best time to buy and sell stock. This problem it was kind of tricky for me to actually find the solution, but honestly, I didn't know how to find the best solution, but I found a solution that was time limit exceeded for this problem. But so we'll go over that because I think it's a good learning opportunity to know how to come up with any solution while you're dealing with arrays. Okay, well, let's go over the problem now. It says you are given an array prices where prices at I is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return 0. So we are given an example of prices, which is our prices array, and then where each item in this prices is going to be the price of the stock in the ith day. So that means at the first day it's going to be 7, on the second day it's going to be 1, third day 5, fourth day 3. Okay, I'm going to show you guys what this means. Let's just say we're given an array of these numbers right here. I just plotted it out on a graph because I did it beforehand. I did this problem, but I just wanted to show you guys a solution. So 715364, 715364. And then our output is 5, because if you do 6 minus 1, that is going to equal to 5. And as you can see over here, we have a minimum over here and then a maximum over here, but it has to be in this range, going forward. So we can't do something like 7 minus 1 because going backward, that means that's in the past. So we can't sell our stock in the past. We actually need to keep going forward in the future. And that's how we get output of 5, even though 7 minus 1 is 6. I guess further ado, I guess you guys know the problem now. And so let's come up with the solution. The first solution I had is, why don't we just go through all the elements in so you guys see over here, go to the first index and then check to see if every other item is going to give you a maximum value or something. So what that means is, I already computed it all. So that means what we're going to do is we're going to go to the first. We're going to set our first pointer to 7. We're going to set our second pointer to 1. So then you do 7 minus 1, and that's equal to 6, right? Then you go to the next one. You do 7 minus 5, 2, go to the next one, 7 minus 3, 4. And then we're keeping all of this into what is the maximum it can give us. So if you guys can see, the difference here is 6, but we're kind of looking for a maximum, right? And since it is positive, that means it's going negatively down, right? Because if we do 7 minus 1, this is going to give us 6. What we actually want to do is 1 minus 7, which is going to give us negative 6, because we're actually going downwards. So we need to use this j value to subtract it. So you guys see how everything is positive if we do that, just by doing I minus j. You actually need to do j, which is 1 minus I, and that should give us our actual value of negative 6, because it's going downward. Let's just see, all of this is negative, right? Negative, 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 negative. So if you just times all of this, that means we're gonna have to actually, we want the maximum value for that that position. So let's say if we were making a list, so in this index we're gonna want this we're going to put -1 here because we're going to calculate the max of these negative numbers. Just like times it by -1. Hopefully you guys can do that in your head. So if you times this row by -1, we're actually going to have 5 as our biggest number here. 5. Okay. Times this whole thing by -1, you're going to see that this is going to be -2, 1, and -1. So this is going to be 1. And then now we have this 6 and 4. Actually, it goes 3 and 6. It's supposed to go 3 and 4. Whoops. 3 minus 4 equals -1. 6 minus 4, which is going to give us 2. Okay. So if we do, if we just get rid of this, then we're going to see -3, -1. What's higher? This 3, because you times it by -1. So 3. And then this one is going to be 2. Actually, it's going to be -2. So then if we loop through all these values after we create this like the sum of every number in its place, and we get the max, sum of max list or something like that, then we just return this 5 because we just need to loop through it once. So that means if we have like one pointer, we go here, is this the maximum value? So let's say our max is gonna be at like 0. Then we say, okay, is this value bigger than 0? No. So why do we set our max to 0? Because in here we want to output 0, right? So if you can't achieve any profit, then you put 0. And this right here doesn't achieve any profits, it's -1. So here, I equals 5, then we change this maximum value to 5 now. So this is going to be 5. And then we're going to check, is 1 bigger than 5? No. Is 3 bigger than 5? No. Is -2 bigger than 5? No. So then we return that value. So that is a solution, and it's going to give you a time limit exceeded solution, but I'm just going to code it up so you guys know how to code this solution. If you guys like ever are stuck on a problem and you literally can't find the best solution, I think it's better to like code this up than not find a solution at all in like your coding interviews. So and since we're gonna do it in Python, let me give you an example. So we need to come up with let's set our max to 0, and then we're gonna loop through this list. So if we set our max to 0, then let's loop through the prices list now. I literally don't know the best way to do this, like a double for loop. But what I usually do is I do this and enumerate prices at I plus 1. Gee, something like this. So what is happening here, right, is when we do I enumerate prices, that means we're going to go through every value in this list, in this array, this prices array, right? But we're going to give it an index as well. So if our index is here, then that's where our index is going to be. And then we do j value here, because if we do I plus 1, that means if our I is over here, our j will be over here. And then it's going to give us 5, 3, 6, 4 as our list. So then we actually need to calculate all the values as well to put all these numbers in here, right? Actually, we don't even need to calculate these values over here because we're already storing the maximum value here. So yeah, we don't even need this list if we're just already keeping track of this maximum value. So then you do if I value, the value of I plus the value of j, if it's greater than, actually you do, how we do it is we do j minus I. So that means this 1 minus 7, right? J minus I. So that's why we do it. If j val minus I val is greater than our maximum value that we have right now, then we would set our maximum equal to j val minus I val. Okay. And then that, I think that's about it. We just return our maximum value here. I'm gonna check it. Let's see if this works. So yeah, it's, what it's gonna do is if we actually print out all the, let's print out j val minus I val, so you guys can like see what this is actually printing out, right? It should print out all these numbers, -1, 5, 1, 3, -2 on test case 1. Wow, what? Oh yeah, okay, it should print out these numbers come from this one, right? Because we do the negative values, and these numbers come from 4, 2, 5, 3. So just do times -1, you guys see it? So yeah, it's printing this array correctly. Okay, if I submit it, it's not gonna work because we're gonna get a time limit exceeded, because this, what we're doing is we're calculating all these values, right? So for every like I value, we're gonna be n squared. So if we get like a bigger array list, this thing is gonna like go exponentially upwards or something like that for the time. And our space, so this time is this time equals here. Space is going to equal to O of, it's actually constant space because we're not actually keeping a list of this array list. We're actually just keeping track of this maximum value, which is only, it's always going to be one space that we're holding for that. But yeah, it's going to be TLE, time limit exceeded. So you can't use this solution, but it's a good solution if you don't have anything to code, I guess. So now I'm going to code it in Roblox, this time limit exceeded solution, because you guys might be wondering how to do it in Lua as well. So what we need to do is first we need to make a max value, a maximum counter. So we would just say local max equals 0. Then what we can do is, well, we need a list of numbers, right? So we can just pull that from here. Let's make a function actually, so we can call this function, which is called max profit. Max profit from this list. Okay, then we can just print out our max profit and give it the list. Okay, so we set our max to here, then we just loop through the list with I. So how we do that in Roblox, we can do for I equals, I think we have to actually go like this. We have to do it like this way, but we have to start at 1 because Roblox here list starts at 1. We need to do it like this way so we can have a j value, and we can start the j at I plus 1. So for j equals I plus 1, then you can do all the way down to the list. And we actually don't need this incrementer because in Lua it automatically pluses 1 to it. So what we can do is we just say if list at I, actually we need to do j because we're doing this j value, which is 7. If j minus 1, I mean j is this 1, my bad. So if 1 minus 7 is -6, then we're going to generate this list. You guys know how it is. So you do the j value there, and then you do list I. And then what we can do is we can say, so if this is true, then we would set our max equal to list at j minus list at I. So this needs to be greater than our max value that we have already. So then we can just return 0 here. And then I'm going to have a list too, so we can see that it works with the other, with this solution as well, or this data set, test data set, I guess. So then this should work. Let's print it out. So then 0, 0. This nil is coming from a different script, guys. Don't look at this, sorry. Yeah, we're just getting 0, 0 for these two values. So that's great. Wait, is it great? No, it's not great. What am I doing wrong? Oh my god, why am I returning 0 here? My bad. Sorry, I have no idea why I'm returning 0 all the time. Okay, now it should work. Like 5 and 0. Okay, that's good. Whoops. Okay, so that's how you do it in Lua. Now let's go to our other solution, guys. So this is the n squared solution. Another way we can solve this problem is, let me give you guys a better example, okay? Because it's kind of hard to look at it with this example, this graph, so we're going to use this graph instead. So what I did over here was I replaced the second value with 3, and I changed this fourth value with 1. So what we do is we check this j value, and if the j value is less than the I value, then we would move our I value over here. So why would we do that? Because, so you guys see at this 6th position, or at this 5th position actually, our max value right here is going to be 5 minus 3, which is going to be 2. So that means if our lowest point is over here, and our new lowest point is over here, then we should move our new lowest point over here. So we don't use this lowest point for this 6. Alright? Hopefully that makes sense to you guys. Because we want to actually use this 1 for this 6, because that's going to be giving our biggest range of, number, right? So that's why we would update our I over there while we move to this graph. So if we check okay, if our j, let's look at this example, okay. So what we do is we initialize our I, which is our left pointer, and our j, which is our right pointer. So I probably should name this right, and this should probably be left, right? So if we put our left pointer at 0, which is a 7, and our right pointer to 1, which is 3, that's how we're going to start this out, and our maximum value is going to be 0. Then, since our right pointer is less than our left pointer, we're going to put our left pointer to our right pointer. That's what this swap thing is. It says put our left to our right, which is 1, and our right, move it right 1 time. So that's what this swap is, and our maximum is still 0. But when our right pointer is greater than our left pointer, then we would calculate the value, which is 5 minus 3, and that's going to give us 2. Then we're going to get this 2, and we're going to set it to our max position, our max pointer, because we're going to be like, okay, is 2 bigger than our current maximum value that we have? And it's going to say yes. Then you set this max pointer. Then we're going to be like, okay, now since we did this calculation already, that means move our right pointer here. So it goes to 4. There's actually 3 things that are happening here. is we're doing this 5 minus 3. We're setting our max value, then we're moving our right pointer here. So then it's gonna be like on this iteration, it's gonna be like, okay, is our right pointer less than our left pointer? If our right pointer is less than our left pointer, then you would put our left pointer to our right pointer, move this right pointer to the right side of it. Then it's gonna be like, okay, our right pointer is now bigger than our left pointer, so then you do 6 minus 1 is 5. You put our maximum to 5, and then after we do this this 6 minus 1 thing, we're gonna move our right pointer here. That's what this iteration is reading. So then we're gonna be like, okay, so our right pointer is still bigger than our left pointer. We're gonna calculate it, and it's gonna be 4 minus 1 is 3. Then it's gonna be like, okay, is 3 greater than our current maximum value? And it's gonna say no. So then it's going to move the right pointer here, and then it's going to go out of bounds. Then you don't do anything, you just break out of this loop because you already calculated the maximum value, and that's how you get your answer. Hopefully that makes sense, guys. So I'm going to use this to code our Python solution. So we still need to set our max pointer to 0, right? And what we need to do is set our left to 0, right to 1. So we can just do that with for loop, which is I val. And then we can do enumerate over prices. We still do this thing, but then we can say I actually think we still need this this double for loop thing in prices, because we still need the I and j value. But in here we're gonna check now if our, how did we do that? We need to check our right and left, okay? Our right and left value. So if our j value is, so if our j value, we're gonna just say, we're gonna just call this right, and we're gonna call this left. Hopefully that makes sense to you guys, since I'm using this left and right pointer now. So if our right value is greater than our left value, so let's say over here, actually maybe we should just do the left first. So if our right is less than our left, then we just set left equal to right. Else what we can do is we just increase our right value plus equal 1. But we do that, like, you know, after we check 5 minus 3 equals 2. So we do right minus left. If our right minus left is going to be bigger than our maximum value that we have right now, then we set our maximum to right minus left. Then after if we check that it's bigger than our max value, and then we set it to our max value, then we increase the right pointer. And then I think that's about it, guys. So our right pointer will get out of bounds. Our left pointer is going to go all the way. I'm now thinking we shouldn't use a double for loop here. What I think we should do is do a while, because I don't really want it to go all the way to, I don't want our left pointer to go all the way here, right? So if it's over here and our right is here, then it's going to try keep moving our left one. And then it's going to then it's going to keep trying to do something over here, but then it's going to be like, oh no, right is actually out of bounds. now that I'm actually looking at it, yeah, we definitely need to use a while. So while right is less than length, our length of prices. So then when it gets over here on our right side, then we're going to break the loop. That's what I've figured out as I was doing it, I guess. Now I actually have to set our left to 0, right to equal to 1, right? Because that's how we initialized it. I seriously should be looking at these notes. It's so helpful. Okay, output 4. How did I get 4? Expected 0. I'm supposed to actually do prices. I am very interesting here because this needs to actually be the value. Sorry, my bad. So then now it should work. So if we run this code, sorry, what I needed to do is actually use the actual number in it and not left and right. So then, yeah, it should work, guys, pretty fast. I don't know why when I talk about like runtime, our runtime is O of n because we're just looping through this as we go. So we're just moving, we're literally having this right one keep going all the way right and never stop. It only stops when it's like, okay, so when it's over here, then it goes here. But then we still move the right pointer, so this right pointer actually still never stops. And our memory, our memory is going to be constant because we're just using this left, right, and max pointer. Memory. How would we do that in Roblox now? So this one is going to be of our ON2 solution. So we still set our max value. This seems correct. And then hopefully you guys see what we're doing here. You know, we're still going through 7. Like if I is at 1, then we're just, so if our I is at 1, then our I is going to be at 7, right? Then our J is going to have this list of numbers, which is this. So our J is going to iterate through all these numbers. So that's why you do I plus 1. Okay, now we just do if our list at J minus list at I. We probably, no, we can't do this. I already know what the problem is. We actually just need to use our while loop because that's how we know our right is going to be out of bounds. So while, and we actually need a left and right pointer too. Local left, right equal 0, 1. So while our right is less than our number of list, then what we do is, if our list at right minus list at left is greater, wait a minute, yeah, the right, if the left side is, if our right side is bigger, no, if our right side is less than, okay, I need to stop guessing. If our right side is less than the left side, then if our right side is less than our left side, then we would set left to right, okay? Else what we would do is we would now check list at right minus list at left. If this is greater than our current max value, then we would set our max value equal to this. And then we would say right side increase. I think we can do plus plus in Roblox, but I guess not. Right plus equal 1. Then we return our maximum and we should be good. So hopefully that makes sense to you guys. Oh my god, if I list that right. You know, I still need to get used to Roblox right and their tables. So that was the only problem. Caught that kind of quickly there. So 5 and 0. So that is our actual solution here, 5 and 0. That means we're done. Hopefully you guys enjoyed, and I'll see you in the next one. Goodbye.